Welcome back, minions, to Nick Does Maths. We're going to have a bit of fun today. We've got an equation all to do with functions. We have an equation that we need to solve, but my solution is an entire function. Bosh. So first of all, we're going to say k is not equal to 1 here, and we'll come back to the case k equals to 1 in part 2. But basically, can I find a function such that f of t minus k times f of 1 minus t is t? Okay. So let's just jot it down here. Now, there's a little hint to the question which I've rephrased a little bit, which is let's consider t as 1 minus u. So what would happen if I replace t with 1 minus u? Now, 1 minus u is u. Important thing to note here, u is just a dummy variable. It can be anything I want. So I could just replace it back with the letter t. It doesn't matter, right? Instead of writing u, I'm going to write t. That's all I've done. Well, I have two equations here, equation 1, equation 2. So what I'm going to do is I would quite like to get rid of the f of 1 minus t. So I'm going to do equation 1 plus k times equation 2. So that will give me f of t minus k squared f of t. The f of 1 minus t's will cancel out. That's equation 1 plus k times equation 2. So f of t, we can factorize out there, is k plus 1 minus k lots of t over 1 minus k squared. And this is where we see the importance of k not being equal to 1, because if k is equal to 1, we would end up dividing by 0 here, which is no bueno for me. No good, no good, no capes. Okay, so that's why k can't be equal to 1. Now in part 2, why can't k be equal to 1? Well, let's just take a specific case for this one. So let's have a look. Basically, we're going to take k as 1, and the rest of part 2, we're just going to look at generic g of t. But first, what would happen to this if g of t, if the right-hand side was still t? What would happen? Okay, what would happen? Well, I could always put k as 1 into here, couldn't I? I could always put k equals 1 into here. So k equals 1 into here comes f of t minus f of t. The left-hand side becomes 0, the right-hand side becomes 1. So in fact, k equals to 1, there will be no solution to this, right? There will be no solution to this. Right-hand side is t if k is 1, because we would end up with 0 equals to 1. Unlucky, unlucky. Try again. Royaume-Uni, nil point. All right, so we know that this one here, when k is 1, t on the right-hand side doesn't work. So can we find a condition for g and t for this to work? All right. I'm going to take back over the board. Take the board back over here. And let's see what happens here. So this is part 2. So we are saying f of t minus f of 1 minus t is g of t. We can do our same trick. Replace t with 1 minus t, essentially. Okay? Equation 1, equation 2. So what's my condition? Well, if I do equation 1 plus equation 2, I end up 0 is g of t plus g of 1 minus t, which really is telling me that g of 1 minus t is minus g of t. So I need that as a condition. So long as g satisfies that condition, I can find a solution in whichever way we do it. But this is an absolute must-have. Cool, done. All right, well, let's find a solution for g of t is this. All right, so we're going to find a solution for this g of t. So I need to find an f that satisfies f of t minus f of 1 minus t is 2t minus 1 cubed. But here's the thing. We've just found a condition of g and t. Now, we could actually, probably should make sure there is a solution, right? g of t is 2t minus 1 all cubed. So what is g of 1 minus t? That is 2 minus 2t minus 1 cubed. That is 1 minus 2t cubed. That is minus, well, let's do one extra step here. That is minus 2t minus 1 all cubed, and that is minus 2t minus 1 all cubed. Solid, solid. So we will have a solution because g of 1 minus t is negative g of t. So we do know that g of 1 minus t is minus g of t. How about we be a little bit sneaky and we try and solve this in general? Because really, do I want to try and find, I would need to take a wild swing on f of t to try and make it come out as g of t. Now, g of t is a cubic in our case. G of t is a cubic. So a solid guess would be f of t is a cubic, and we could play around with that. But here is my suggestion. How about we take a wild swing and we're going to say, can I find a function by saying it's going to be something times g of t? Something times g of t. Well, f of 1 minus t is h of 1 minus t, g of 1 minus t, but we know that that is minus h of 1 minus t, g of t from that condition. So f of t minus f of 1 minus t has to equal to g of t. Let's plug in what we know. So that tells me that h of t, g of t, plus minus minus h of 1 minus t, g of t is equal to g of t. So I've got myself to working out some function that h of t plus h of 1 minus t is 1. Now we can start looking, but how about we look for something that is linear? How about we look for a linear function? Well, h of 1 minus t is there. So if I add them, I need to get 1. Well, what's kind of cool is that the t's cancel out. So this gives me a plus 2b equals 1. So this is completely possible. I could take b is 0, a is 1. I could take option 1. I could take, tell you what, take a is 0, b is a half. In which case my f of t becomes, b was my coefficient here, just becomes 1/2 g of t. That'll work no matter the g of t. So I've now got a nice condition, and to be fair, this 2t minus 1 cubed becomes entirely irrelevant. Just play around with that. I could take b as 0, and then a would be 1, so I could take my function to be t g of t, and you can try that out. That will also work. That will also work. And you can play around a little bit more. How about I try h of t is a cubic, is a quadratic? It turns out you can't. That is impossible. It doesn't work. Do the same trick, right? And you can take any combination thereof. All right, we could take a as a half, b as a quarter. In which case, f of t comes 1/2 t plus a quarter g of t. Any of these will work. And then we can just sub in g of t is 2t minus 1 cubed. So the red herring here, really by and large, is trying to force you to do it with this particular g of t, which is not great because you end up with a cubic. And you have to match all the coefficients. However, if we take a step back and think, well, we've just found a really neat condition on g of t, how about I try and leverage it? And that's kind of funky there as well. Did we find that interesting? Did I make a mistake? Can you spot other forms? I've gone for linear here. I'm going to claim that quadratics are impossible. Try it yourself. Tell me what you think. Could h of t be in a cubic? Could h of t be, could Could we have gone h of t is some form of trig function? Interesting. Tell me what you think. In the meantime, don't forget to like, subscribe, hit that bell so you get notifications. I'm Nick. See you soon.